I'm going to go over with you section 1.1, which is all about graphs and graphing utilities. Here are the objectives for this section. So this is an overview of the coordinate system. We have the x-axis, the y-axis. Where they cross is called the origin. The quadrants are labeled 1, 2, 3, and 4. Positive numbers go to the right, so this would be like 1, 2, 3, 4, and so on. Positive numbers on the y-axis is going up, 1, 2, 3, 4, and so on. If you go to the left of the origin, you're going on the negative x-axis. If you're going down from the origin, negative y-axis. Each point in the rectangular coordinate system corresponds to an ordered pair, x, y. X represents your left and right, or left or right, I guess. And then the y represents either going up or down. First number in each pair is called the x coordinate, and the second number is the y coordinate. So when we plot a point on the coordinate system, you start at the origin. So this negative 2, 4, x is negative 2, y is 4. So we would start at the origin, go left 2, and 4 is up 4. Negative 2, 4. So this coordinate represents negative 2, 4. The relationship between two variables can be expressed as an equation in two variables where you have x and y. The solution is where there is an ordered pair that is part of that solution. When the x coordinate is substituted for x and the y coordinate is substituted for y in the equation, we obtain a true statement. So if we have this, we could get a set of ordered pairs from our table. So I'm going to review how to do that in the calculator. I'm going to go to y equals, clear out whatever is in there. So this was y equals. Let's put in 4 minus x squared. And we can hit second table to come up with some numbers. So I'm going to do negative 2, 0, negative 1, 3, 0, 4, 1, 3, and so on. So these are coordinates that you could graph to construct this equation or this situation, this function. Then if you hit graph, you can also look at the graph. These coordinates are each plotted on this graph to make it look that way. Because it has the x squared, this is a quadratic function. Let's go to example 3. Graphing an equation using the point plotting method. These lines right here represent absolute value. The quadratic was the U-shaped parabola. Absolute value is a V shape. Looks like this. So we could use the table of values to find our coordinates using the calculator. So it says select integers for x starting with negative 4 and ending with 2. So negative 4, I'm going to go up to 2. Negative 3, negative 2, negative 1, 0, 1, and 2. For absolute value, we are substituting in a value for x, and whatever comes out is the output, which is y. So we do absolute value of negative 4 plus 1, absolute value. You do the operation inside, so that comes out to negative 3, the absolute value of negative 3. Remember, with absolute value, it comes out to be a positive, because absolute value represents the distance to 0. So you do that for all of these. Okay, we can also do this in the calculator. So go to y equals, let's clear out. We need to find the absolute value. So let's go to math. It might be in here, or it might be in our catalog. Oh, it's under number. So I clicked math and then over the number, put absolute value, and it brings up those absolute value bars. So it'd be x plus 1. Then I can go to the table of values, and I'm going to go, so negative 4, 3, negative 3, 2, negative 2 is 1, negative 1 is 0, 0 is 1, 1 is 2, 2 is 3. If you don't want to do the table of values, you can also do absolute value for each one of these. So you, again, go to math, over to number, absolute, put in negative 4 plus 1, enter. That to be 3. So those are two different methods. So after you come up with your table of values, you're going to graph using the point plotting method. That means you're going to plot points. So I need to plot these points. Negative 4, 3. So that means I'm going to go over to negative 4, up to 3. Then negative 3, so I'm getting them from my table of values, negative 3, 2. Negative 3, 2. Negative 2, 1. Negative 1, 0. 0, 1. 1, 2, 2, 3. And you would connect the dots. And remember how I said absolute value is actually a V. And we know this is going to go on and on forever. So there's arrows that represent on and on forever. Absolute value function is a V. Looks like a V anyway. Okay, graphing utility. You can change your viewing using the window function. So I graph it just to look at it. I can change my window. The window is what this looks like. The standard window, if you just hit window, after you've cleared your memory and everything, remember, it goes back to standard, or you can hit zoom 6 for standard. This is my standard viewing window. And what it is it goes positive 10 to the right, negative 10 to the left. So it's negative 10 to 10. And then the y-axis goes negative 10 to 10. But I can change it. We can change our window to be anything we'd like. So let's say we want to go negative 100 to positive 100. And our scale is going to be 50. So what I'm doing is actually this. By the y, so this first represents the x values. By this, x by y, the y values. So I just want to change it just so I can see what it looks like. Y min would be 100, y max would be 100, and my scale is 10. Once you change your window, you can hit graph and you can look at it. So whenever it gives you the first set of numbers, that represents your x values by whatever your y values are. First number represents the minimum x value, negative 100. Second number represents the maximum x value. Distance between, this is your scale, is 50. So if you want to put that to the side, scale. What is it going by? That's our scale. And then the y values are your second set of numbers. So our min is negative 100. Our max is 100. And the distance between tick marks, which is your scale, is 10. So you can always change your window if you would like. If you want to go back to original, you'd hit zoom 6, which is standard. Zoom, yeah, it's Z standard. Whenever you do that, it takes it back to the original standard negative 10, 10, 1 kind of window. The intercepts. X-intercept of the graph is the x-coordinate of a point where the graph intersects the x-axis. So x-intercept is where it crosses the x-axis. And your y-intercept is where it crosses, y-intercept is where it crosses the y-axis. There we go. So an x-intercept is when the y-coordinate is 0. So you have a value for x and y is 0. That's your x-intercept. Whenever you're finding your y-intercept, the x-coordinate is 0. So it's 0 and then a y value. So on our last example, we can look and see what our x and y coordinate intercepts are. So our x-axis is right here. So you can always push trace. When you hit trace, it'll go, usually everything I've found so far is that it goes directly to our y-intercept. So 0, 1, that's my y-intercept. And then we can go to our x-intercept here, which is about that. You can hit, let's see, second trace, which is calculate. And we want to find the 0. And so we'll go to the left side, push enter. To the right side, push enter. Yes, push enter. And that gives you a 0. An x-intercept is also called a 0. You also see the word root and solution. That's your x-intercept. They all mean the same thing. So we'll be seeing that later on in the semester. Okay, our last problem, identify the x and y intercepts. So our x-intercept is where it crosses the x-axis. So this is our x-intercept. It's at -3, so the coordinate is -3, 0. And then our y-intercept is where it crosses the y-axis. So see, this is y. It is at +5, which would be 0, 5. That is it for today's notes. I will see y'all next time.